Yeah, you're good. That's
Okay.
Yeah, I'm just gonna post the link and then I'll send it back. That'll be free.
Sorry?
Yeah, I'm just posting the link.
Alright, just let me know when to start.
All right. Yeah, you're good.
Hey. Alright, everyone, we're going to get started here pretty soon. So just before I get going, I just want to remind you that we're going to be posting the feedback form in the Facebook event page. And, we really do appreciate if you can guys just have 5 minutes during the break to fill that out. If you do, someone in this room will win a $10 Starbucks gift card. So that'll be helpful for those late night studying sessions. So just make sure you go ahead, do that. It'll only take 5 minutes. So let's get going here. My name is Ryan Deemert, and this is going to be the COMM 298 CMP review session. So just a little bit about me first. I'm a third-year finance student. When I took this course about a year ago, I finished with a 92 average with Darren DeGraff, so hopefully that makes me a little bit qualified to teach this here. I'm from Calgary, Alberta. Here's my email if you guys have any questions regarding anything really up until the midterm. Don't be afraid to shoot me an email, and I'll do the best that I can to help you guys out and answer those questions. So, just some general tips here. So, the most important thing with finance and finance tests is to read the questions carefully. Like the number one thing that professors are going to try and get you to do is they're going to try and trick you. They're going to try and give you monthly APRs, bonds that are semi-annual or weird interest rates. The point is that you need to make sure that you read every single question carefully, and if you're putting it into a formula, make sure that's what the formula is asking for. So I think you guys have until Thursday for the test, so the best use of your time is going to be to practice, practice, practice. Do all the practice problems you can, go through your lecture notes, and the most important thing is do your practice midterms. That's the number one way you're going to find success in this course. If you guys get stuck on something, first thing that I would do is draw a timeline. It helps you visualize the numbers. It's the best thing that you can do in finance. And don't be afraid to skip your questions and come back later. Now, about this session, because there's 3 or 4 professors, they all have completely different material. It's going to be hard for us really to go over everything that all the professors are going to be teaching. And we're going to cover some things that other professors don't teach. So if you see something that you haven't seen in lecture, don't freak out. Just make sure you go back in your lecture notes, make sure it isn't there. If you don't see something here that your professor taught, make sure you go back in your lecture notes, because that's really going to be the number one source of where you're going to find out what is and what isn't on that test. So let's get going here. The session is going to go over the major concepts in this course for pretty much all the sections, and that includes the time value of money, discounted cash flows, also known as net present value, interest rates, HPR, holding period return, and finally, bond valuation. And we're going to take about a 5-minute break, about midway in between, just so you guys know. So if you guys want to take a bathroom, ask me questions, fill out the feedback form, that would be the time to do it. So, before further ado, number one section is time value of money. This is pretty much the core of this course and the core of all finance, and it's all centered around the principle that $1 today is worth more than $1 tomorrow. I'm sure you guys have all heard that before in your course, and that's because it's just so true and so important that you understand that conceptually. So the first section is future value, and it's also known as compounding. Now, this is basically the basic formula of future value. It's annual compounding. And if we quickly look at an example where we have a present value of $100, an annual interest rate of 5%, and a period 3 periods, we can see this is basically the formula that we'd use, and this is how we put those numbers into the formula. And if we would to visualize that in a timeline form, this is what we'd see. So we start with $100 in the present sense. We times that by 1.05, and that's applying that interest rate. That's what you get when you're moving the money into the future from your perspective, in the present, right? So in order for us to kind of forego money and, loan the money out, anything like that, we're going to be charging an interest rate. And while that money is in the bank, in our account or whatever, that interest rate is going to be applied. In annual compounding, that interest rate is going to be applied every year. So this $100 is times by 1.05. That's 105. It's times 105 is times by 1.05. Becomes 110.25. And lastly, it's times again by 1.05, bringing our grand total and our future value to 115.76. And this is kind of, I guess you'd say, the brute force method. Most of the time, if you're asked to find a future value, you're going to use this formula, and it's pretty much just done by plugging those numbers into the formula. The second concept is M per year compounding, and that's pretty much put forth through this little formula right here. Now, as you guys realize, and I'm sure you've heard in your lecture, a lot of times you aren't just going to be given, an X annual interest rate. You're going to be given, say, a 6% monthly APR, a 20% daily APR. And you're going to use this formula to kind of deal with that. So again, it's pretty much the same thing as this, but you're going to put that daily APR, that monthly APR, into this R. Make sure it's on a yearly basis. This M is the amount of periods that are in a year. So if it's monthly APR, there's going to be 12 periods in a year. If it's quarterly APR, there's going to be 4 periods a year. This N is the number of years, and this M would be, again, the number of periods in a year. And that's how you're going to find that answer. So firstly, let's just go, and once we review the concept, we're going to do practice problems. Just go through that. If you guys have the materials printed out or on your phone, just make sure you guys can follow along and do it for yourself. So number 1, Joey takes out a $1,000 bank loan that has an 8% APR in a time period of 5 years. How much money must Joey pay back at the end of 5 years? Well, obviously, if we're looking at a future value, a future point in time, we're going to be using the future value equation. We're going to be looking for that future value. We can see here that the present value, the money in the present. Sure, yeah. Is that good?
A little bit.
That's good. All right, so we're going to be using the future value formula. The present value is the $1,000. Just if we're going to look this on a timeline, we can see that he takes out that $1,000 out right now, right? So that would be the present value. The interest rate is 6% APR. It doesn't say anything about a period APR, so it's, again, just plugged it into this formula. And at the end of 5 years, again, that means that period is at the end of 5 years. We're going to plug that all into the formula, and we're going to finish with $1,469.33. That's what you guys should all do the same way. In finance, in this course specifically, the math you're going to do really isn't too bad. It's just making sure that you can read the question, understand the concepts, being able to put it into the formula and get the right answer. So let's do the second question. This is going to be dealing with the M per year compounding. The question reads, Monica's credit card has a 20% daily APR. If Monica's credit card balance is $150 today, what will it be in 2 years? So again, we're seeing 20% daily APR. That means that we aren't going to be using this annual compounding. That means that the interest rate is going to be applied every single day. So we're going to have to use this formula. So we have to find the present value. Obviously, it says $150 today. That will be the present value today. 1 plus R divided by M. R is going to be that periodic APR, which is 20%. M, well, it's asking us to find the daily APR. Use the daily APR. There are 365 days in a year, sorry. I think there might be a typo here. 365 days in a year, so that M is going to be 365, because that's the periods per year. N, 2 years, obviously, so we're going to put that N in there. Again, sorry, there might be a little typo here, but you're going to plug everything into the formula pretty much like this, and you're going to get something like $223.75. Now again, if you guys have any questions, if they're little things, just don't be afraid to ask me, but if there's anything big you want me to go through, any problems or anything, just try and keep it to either the end of the session or at the 5-minute break. So before on, let's move on. This is pretty much the opposite of future value. It's present value. Basically what we're going to be doing is we're going to be discounting things and moving them backwards into the past. Formula is pretty much the reverse of the future value formula. Present value equals future value divided by 1 plus the interest rate to the exponent of the time period. So the same thing, let's take $100 in future value, interest rate of 5% in a time period of 3 years. So again, with present value, $1 tomorrow is worth less than $1 today. Now all these values on this timeline, they're all worth the same thing. You'd be okay with taking any of these points of money, these amounts of money at these specific points in time. That's because, again, this amount of money is going to be worth more because it's more in the present. This money is going to be worth less because it's more in the future. Now again, let's plug those same values into a formula where it's $1,000 divided by 1 plus the interest rate, the exponent 3, and we're going to get $86.38. Pretty easy. It's just, again, just plugging numbers into a formula. The hard part is being able to draw this timeline out, visualize, and understand the questions. Again, we have the MP year discounting, pretty much an identical formula here. So let's do the practice question. So Chandler has been proposed 2 deals by his friend who owes him some money. In deal A, Chandler will receive $500 in 4 years. In deal B, Chandler will receive $450 in 2 years. Chandler's interest rate is 5%. What deal should Chandler take? Now you guys will probably see a question pretty similar to this, where you're asked to look at 2 separate deals and find out which one is better. Again, what you're going to do is you're going to be equivalent them, making them be the same through future value or present value formulas. So let's start with deal A here first. So we're going to take the future value of $500. The time period will be 4 years, and the interest rate will be 5%. Again, this is just pretty much simply reading the question, making sure you guys have the right values, and we're going to be getting $411.35. Now let's take the second deal, and let's bring it back into the present value, the present tense. So again, we have $450, and we have 2 years. Plug that into the formula, and we're going to get the present value of deal B is $408.16. Obviously, deal A is worth more than deal A, or deal A is worth more than deal B, so we're going to take deal A. Now, let's move on to the next section, which is discounted cash flows. If you guys had the graph, I think he calls it net present value. This is probably going to be one of the sections that deviates a little bit through the sections, but I mean the core kind of concepts are all the same. So the first subsection is annuities. So you have 2 types of annuities. You have the ordinary annuities, and that's when a fixed amount of cash flows, that means the same amounts every period, is received with the first cash flow occurring at t equals 1. Now that's probably the most important thing with annuities, making sure you remember that when you plug things into the annuity formula, that first cash flow is coming at the end of the first year. So make sure you guys do a timeline for the annuity. An annuity due is an amount when a fixed amount of cash flows with the first cash flow occurs at time equals 0. So that's the difference there. Let's start with a present value of an annuity. So again, we have these amounts of values here. So this is pretty much how I do kind of a brute force method. Net present value is I take all my cash flows, I put them in a timeline format. So n equals 4, which means you're receiving $50 at 4 times, in 4 years. The first cash flow is coming at the end of the first year. You're going to be discounting all of these because it's asking for the present value. So you're going to be discounting that by 1 plus the interest rate to the time period that you're at currently. So this is going to be the first time period. It's going to be exponent 1, second period exponent 2, third period exponent 3, fourth period exponent 4. You're going to take all of these values, add them all up, and the present value of this annuity is going to be $158.58. Pretty simple. Now this is the formula here. It's pretty much finds you the exact same thing as this. So, whichever one you guys want to use, it's up to you. For me at least, I like doing it this way. It just keeps everything simple. But But of course, you're going to get times when you have to add 20 different cash flows together, right? So it's just not practical to use the timeline net present value method. So if you want to use the formula, this is it. I'm sure you guys will have a formula sheet for your test. You just plug all of these values in. The C is the cash flow that you're receiving every period. The N is the amount of cash flows, and the R is the interest rate. You're going to find that you get pretty much the same thing. Again, there's a little bit of rounding, kind of error there, so you're going to get a bit of sense difference, but altogether these formulas and this method give you the exact same way. It just comes down to what you feel comfortable with using. Next concept is an annuity due. It's pretty much the same thing, but again, you're receiving that first payment right now, right at the present tense, right? So you don't need to discount it at all. So, again, N equals 4, so you're receiving 4 cash flows, again, but you only really are discounting the last 3, because those are the ones that you're going to be receiving in the future, but it's the same thing. You just put the period as the exponent, you add them all up, and you're going to get 174 and 43 cents, which is, of course, the same values, but you're going to notice that an annuity due is worth more than an ordinary annuity, and that's because when you move cash flows this way, they're going to become more valuable. When you move them this way, they're going to become less valuable. A lot of questions are going to ask you to kind of play with that concept. Now, the formula is pretty much the same thing, but you're going to be timesing it by 1 plus the interest rate. Again, all that does is going to move the same stream of cash flows 1 period to the left. It's going to be pretty much compounding it to move it to the left, make it become more valuable. Plug all this in, you're going to get 174 and 34 cents. Now, if you prefer, you can pretty much find, you can use this, and then you can use the future value formula to do the exact same thing. But the important part is that if you see annuity due, you make sure that you remember to compound it once to move the cash flows left on the timeline. So let's do this practice question right here. A retirement package pays $10,000 every year for 10 years. Assume the interest rate is 7%. The first payment is at the end of the year. What is the present value of the retirement package? Well, again, what we're going to be using is our present value of annuity formula. Obviously, we're going to be plugging all of these numbers in. 10,000 is our cash payment. Our interest rate is 7%. And our time period is 10 years. Now, if you see here, it says the first payment is at the end of the 10 years. So again, we're going to be using that annuity formula. So just to quickly visualize that, $10,000 is received right there. So pretty simple stuff. Let's move on. Question number 2. If the first payment occurs at the beginning of the first year instead, what is the new present value of the retirement package? Well, you guys are going to notice that when you move cash payments once to the left, you move them more to the past, they're going to be becoming more valuable. So again, you just compound that once by 1 plus the interest rate, and you're going to get $75,152.32. You guys need to make sure, again, that you draw a timeline out so you can visualize something. If you move something to the left of the timeline, you're going to be compounding it. If you're moving something to the right of the timeline, it's going to be becoming less valuable. So you're going to have to discount that. Question number 3. Ross has just won the lottery. According to the lottery's website, Ross's prize is a present value of $1 million. Ross will receive an annual payment every year for 20 years. Assume the interest rate is 10%. What is Ross's annual payment? Now, you guys are probably going to see a question like this where it's going to ask you to solve for C in this sort of method. It's just the important thing there is to make sure that you know that the present value is $1 million, which means that right now that package is worth $1 million. The interest rate is 10% again, and the time period is 20 years. So make sure that when you do all this, you keep everything right. You make sure you algebraically rearrange this formula. If you isolate C and you don't mess anything up, you're going to find this is how you rearrange that. When you solve for C, you're going to get $117,459.62. Now again, what that means is that for 20 years, you're going to be receiving this amount, And then when you discount those payments at 10%, it's going to be worth $1 million today in the present tense. Now, hopefully this illustrates it a little bit better. Question 4, after talking to a representative on the phone, Ross learns that his prize does not actually have a present value of $1 million. Instead, all of the annual payments that he receives over the 20 years will total $1 million. What is the actual value of Ross's prize? Now that means that our present value isn't $1 million, but if we take all of our payments, all of our C's, our cash flows, they're all going to equal $1 million, which means that our actual C is going to be worth only $50,000. So again, let's plug all of those values into the formula. Our interest rate is the same, our time period is the same, and we're going to get the actual present value of the lottery prize is only $425,678.19. That means that if you were to receive all of those cash payments today, that'll be worth $1 million, but because you're on that timeline, you're on that annuity deal, you're only going to be receiving this amount of money in effect. Now let's move to the third subsection here, future value of an annuity. Now again, this kind of thing, the future value of an annuity, it really helps to kind of draw out a formula just so you guys can understand that. So let's go with a question where we have a cash flow of $50, an interest rate of 10%, and a time period of $4. Now you're going to see that with the future value of the annuity as well, that first payment is going to be received at the end of the first year as well. But you're going to notice that when you receive this last fourth payment, that is the future value, right? So you're not even going to be compounding that at all. So you make sure to keep that into account, that this fourth payment isn't going to be compounded. So if you're going to use this method where you're going to add them all up, you know, this guy is going to be compounded 1, 2, 3 times. This guy's going to be compounded once, and this guy is just $50. So you add all these up, and the future value of this annuity deal is $232.05. And now this is the formula for that equation. Again, you know, I'm sure all of your tests, all of your midterms will have a formula sheet, so don't worry about, you know, being able to memorize these formulas, just being able to memorize what this formula gives you and what you have to put into it. So if we put the same values into the formula, we're going to find that we get the same answer. So again, those are equivalent methods. It's just whatever you guys feel comfortable with. So let's do a practice question on that. Phoebe decides to start saving for a car. She wants to put $1,000 in the bank every year for 5 years, starting at the end of this year. Her saving account will offer a 5% interest rate. The car Phoebe wants to buy costs $5,500. Will she be able to afford the car at the end of the 5th year? So she wants to have a future value of $5,500. And she wants to do that by putting $1,000 in the bank every year for 5 years. So just remember so let's just plug all of these values into a formula. We're going to have 5 payments. That's going to be that end value. Our interest rate is 5% as stated, and our cash flow payment is $1,000, and our future value that we're going to find is $5,500, or $5,500, 25 and 63 cents. Sorry, and that means that she will be able to afford the car. So let's move on. We got perpetuities now. Now, perpetuity is a stream of cash flows that is expected to continue. Oh, sorry.
Sorry, I was just quoting on perpetuities, and I just wanted to ask, anything you can do, how would that affect the calculation of future value?
Sorry? Oh, okay, so if you had an annuity due, I would recommend that basically what you're going to be doing is you're going to be taking this and dividing it by 1 plus the interest rate. So remember that when we have kind of a stream of cash flow payments, you know, this is 0, 1, 2, 3, 4. We're going to look at an annuity, right, or a future relevant annuity right now. We're going to receive a cash flow here, 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 here. Now remember, this is the future value right here, right? That's what we're going to try and find this perspective. So if we're going to move all of these cash flows once to this way, right? That deal, in terms of future value, right, is going to be worth less because we're going to be having to compound those having to compound those more. Sorry.
So just divide by 1 plus the interest rate.
Yes. All right. Any more questions, or are you ready to move on? All right. Sorry, you're actually going to want to multiply by 1 plus the interest rate. That's my bad. Because yeah, again, if you're going to be moving to the left, you're going to move these cash flows to the left. You're going to be wanting, that's going to make it more valuable, right? Because when you think about it in this way, these cash flows are going to have one more period to compound. Okay? So yeah, just again, multiply by 1 plus the interest rate. Any more questions? All right. Sorry about that. Yeah, so you're going to multiply it.
So it's just
Yeah, so if you're moving your cash flows to the left, you're going to multiply it. If you're moving to the right, you're dividing it. So same thing, right? It's all about your kind of perspective, right? All right, so perpetuity. So perpetuities are a stream of cash flows that is expected to continue forever. First cash flow is received at the end of the first period. It's the same thing as annuities. You know, we have that one period where we're not going to receive anything, and then we receive that first cash flow at the end of the period. A growing perpetuity is a stream of cash flows that is expected to grow at G% every period. These are the two formulas. As you can see, they're pretty much identical. You're only going to be subtracting G at the end of this. You're going to be doing R minus G for the growing perpetuities. Now remember, for this formula that you're not going to be doing interest rate plus 1, which is what you usually do in most other formulas. So just try and keep that in mind, that if it's asking for a perpetuity, this is the formula you use. So let's do some practice questions, jump right into those. Rachel's offered a deal where a bank will pay her $500 every year forever in exchange for a lump sum payment today. Rachel's interest rate is 10%. The first payment will occur today. How much should Rachel pay for the deal? So again, let's just use that perpetuity formula. We're going to have the cash flow equal $500 because that's just what it asked. Our interest rate is 10%. We're going to find that our answer is $5,000. Now remember again, that first cash flow is received at the end of the first period, so we don't need to do anything. So, I'm sorry, the first payment does occur today, so we do need to do something. So what we're going to have to do again, same thing with the annuity due, is we're going to have to times that by 1 plus the interest rate to move those cash flows to the left. So our answer is going to be $5,500. So question 2. In an effort to sweeten the deal, the bank offers to increase the payments by 2% every year. Again, first payment of $500 occurs today. How much should Rachel pay for this deal? So obviously, again, we're going to be using that growing perpetuity formula because this is a perpetuity, and instead of receiving our first cash payment at the end of the first year, we're receiving it today. We're going to have to compound that by timesing it by 1 plus the interest rate to move it to the left. And we're going to find our answer for this growing perpetuity is $6,875. So let's move on, and this will probably be our last section before we take a little break here. It's going to be interest rates. So obviously these are the three kind of categories of interest rates you guys are going to see in your test. You have the nominal rate, the annual rate, the APR. That's pretty much if they say like 8% APR, 8% annual interest rate. The most common type of interest rate, and it's also the contract rate. So you 6% APR, 12% monthly APR, 8% quarterly APR. These are all just things you'd actually see on a contract, right? Now, unless it says 6% APR, it doesn't give you a period, it doesn't really mean anything. 12% monthly APR, you're never actually going to be using 12% other than to find that actual effective interest rate, and that's the period rate. And that's the rate you're actually going to be using to discount or compound each period, the amount that's actually going to be applied to your balance every period. So for this 6% APR, that's actually 6% annual APR. That means you're going to have 6% applied each year. If it's 12% monthly APR, it's going to be 12 divided by 12 months, which means that 1% is going to be applied to your balance each month. If it's 8% quarterly APR, you're going to have 8% divided by 4, which means that 2% is actually going to be earned each quarter. That's the actual rate that's actually applied to your loan balance or whatever every year. Now the effective annual rate, the EAR, that's basically taking these types of APRs and seeing what an annual rate would actually be, what kind of interest rate is actually earned during the course of a year. Now again, for this 6%, you're actually effectively earning 6% in a year. Now if we have these monthly APRs, these quarterly APRs, we're going to have to use this formula to make them all the same and find that EAR. So for here, we're going to just, M is that 12, that monthly, because there's 12 months in a year. Pretty simple. 12% is that APR, that 12% monthly APR. We're going to get 12.68. That's the amount that's effectively earned in a year. For this question, we're going to have 1 plus 8%, 8 quarterly APR, 4, because there's 4 quarters in a year. Pretty simple. And we're going to get 8.24% that's effectively earned in the year. This is the equalization formula. This is how you take, say, a monthly APR and a quarterly APR. It's how you make them the same. Now this is basically 1 plus, the actual period rate. This is the amount per year. 1 plus the actual period rate, what's actually earned in the year, the second column. And then this N is, again, the amount of periods in the year. Now I'm going to have a practice question a little bit later that's going to kind of explain that more, but if you have like kind of a monthly APR, you need to make it the same as like a quarterly APR, something like that. This is the formula you need to make them equal. So if you have monthly and annual, you want to make them the same. This would be the actual monthly rate that's earned in a month. The quarterly to exponent 12 equals 1 plus the annual exponent 1. That's how you kind of move that from different periods. Now you might see this as well. This is real versus nominal interest rates. This is how you kind of apply inflation. You might get kind of a bond question where they ask you to use the real interest rate. If you see that, this is pretty much the question. The formula you're going to use. Pretty simple. 1 plus R, the nominal rate, divided by 1 plus the inflation rate. That will give you 1 plus the real. Again, that's just plugging it into a formula. Pretty simple. So before we take a break here, let's do some practice questions. So if we have 10% monthly APR, find the EAR. So again, that's just going to be plugging these values into the formula. Pretty simple, nothing too complex. Just make sure, again, you read that it says monthly APR, so we're going to be dividing by 12 and using exponent 12. 10%, that's going to go there, and you're going to get 10.47. So say we're given 22% daily APR, and we're looking to find the effective semi-annual rate. So if we're going to find the effective semi-annual rate, we're going to be using this formula right here. So again, this is assuming 360 days in the year. Obviously using 365. But so what we're going to do here is we're going to 1 plus the daily rate. This is 22% divided by 360. So again, that's going to give you what you actually apply to your balance every day. Again, that's just what this formula is asking. And then what you need to do here is move that over here. It's asking you again to effective semi-annual rate. How many days are in a semi-annual period? Half a year, 180. And you minus 1, you get 11.62. That means that if you have a 22% daily APR in half a year, you're going to be applying 11.62% of interest. So you can see a question asking you like, again, if you have a 22% daily APR, balance is $100, what is your balance at the end of half a year? You could just do this formula to convert your interest rate into an effective semi-annual rate, and then just apply that using the future value formula. So, lastly, if you have a 15% EAR, effective annual rate, how do you get a monthly APR? Again, this is just pretty simple, just algebraically solving for APR. This is how you do that. You just put that in, and you're going to get 14.06 monthly APR. So that's these are all equivalent, and that's how you find it. So before we start on holding period returns, let's just take a 5-minute break. If you guys have any questions, feel free to ask. Go to the bathroom or anything, but make sure you take the time to fill out that survey, because someone here is going to win a 10% or $10 Starbucks gift card. So thanks. So we'll come back at 6:45.
In case you guys don't know where to find the feedback form, it's posted on the event page where you find information about this event. So if you go on Facebook, it's right there. And so this type of feedback is really important for us because we need to know how well our tutors do. So and as an incentive for you to fill it out at the very end, if you put in your email address, then you'll be entered into a draw to win a $10 Starbucks gift card. So,
Alright, so let's get back into it. So this second half of the review session is going to be pretty much, taking everything we've learned, putting it together, be able to, really solve a little bit more complex problems. This is stuff from this second half, especially the bond valuation, is going to pretty much take up almost the majority of the actual midterm. So make sure when you focus on doing your practice problems, reviewing your lecture notes, doing practice midterms, you kind of spend a lot of your time on bond valuation, just making sure that you know how to do that appropriately, you understand the concepts. So this is going to be the first time when we really actually go through some qualitative concepts as well. So the first section here is holding period returns. That's basically the return that one earns by holding an asset for a period. Pretty self-explanatory title. This is the formula that you use if your holding period your holding period return is non-annualized, meaning that you're just looking for whatever return you've earned. This is the formula that you use if you're looking for an annualized holding period return, which is most of the time they're going to be asking you to find that annual return from holding an asset. Now, the formula is pretty simple. It's just the price in period 1, which is the second period, plus the income. That's the future value of the income. What's the income is worth, at P1. So, you probably won't be asked to do this, but if you receive income in between that, you need to make sure that you take that to this point in the timeline and make it worth that. So you have the present value 1, you're going to be you're going to just put this all into the formula, and that's what you're going to find. Now, say you're given a situation where you're giving equal returns, and you want to find the period return for all of those different periods. You just add those to 1, and you multiply them together. You're going to be given that holding period return. Make sure you add those to 1, and make sure you multiply them. Don't add them, you're going to get an off answer. So let's go through that with this question. So this question is actually pretty similar to one that I received on my midterm with the graph, and it was actually a pretty challenging question that a lot of people didn't do well on, so make sure you pay attention to this question. So the following are quarterly prices and dividends for a stock, CEPK. Prices are from the last day of the quarter, so again that's that P1, and the dividends are paid at the end of each quarter. Again, income needs to be made sure to the value of that P1 time period. If the stock price was $8 at the start of the year, what would be the HPR for holding the stock 1 year? Here's our table right here. Now, again, this question might seem a little difficult, but this was a question pretty much almost the same with the numbers changed and a little bit one that I received on my midterm. So make sure you guys know how to do this. And you're going to be doing this by finding the holding period for each of these quarters and then multiplying them together to find that annualized holding period return. So for this first quarter, our income is the dividend of 5 cents, or 50 cents, sorry. We're going to be adding that to $10, which is the price at period 1, and we're going to be dividing that by 8, which is again P0, the price at the beginning of the period. We're going to be at the beginning, and then minus that by 1, we get 31.25%. That means that in the first quarter, we had a return of 31.25 cents, taking into account the income that we earned during that quarter. We're going to do that for all of these quarters, and we're going to find that in the fourth quarter we earned a negative return. We're going to take all these returns, add them to 1, multiply them together, and then because it asked us for the annual holding period return, but 4 quarters in a year, right? We don't need to do anything. This is already annualized, right? So we're going to find that our holding period return at the end of the day, this should be minus 1, is 54.68%. Meaning that when we take into account the prices that we have through these quarters, the dividends that we had a 54% return. Now, if we didn't have these dividends, you could just take this price here, this P0 and this P1, and just apply that to the formula, right? But you can do that one of 2 ways. You can use formulas, or again, you can kind of use that brute force method of finding all your cash flows, discounting them all, and finding out what that all equals. So the first type of bond is zero coupon bonds. They're also called strip bonds or discount bonds. It's pretty much just a present value calculation done. Fairly simple. F right here is the face value, R is that interest rate, N is the number of years that you hold that bond until it reaches maturity, and P is the price. That's the present value of the bond. Pretty simple. Next part is the coupon value, or the coupon bonds. So let's look at a bond that has a face value of $100, which most bonds will have, a coupon rate of 5%, a time period of 3 years, and a R interest rate of 10%. Now, when you have a coupon rate of 5%, that means that your annual coupon cash flows will be equal to 5% times the face value, which again will makes it so you earn $5 for each of your coupon payments. You'll receive a coupon payment because this is a annual bond at the end of each year. So you earn $5 here, you earn $5 here, and you earn $5 here. And of course, at the end of the period, you earn your face value back, it's $100. So again, there's one of two ways you can do it. You can discount each of these cash flows by the appropriate discount factor. This one just being a coupon payment, this one just being a coupon payment, this being the coupon payment plus the face value. You can discount them all again, add them all up, and you're going to find that you get $87.57 for this coupon bond. So again, you can do that for this, or say you have a 20-year bond with like semi-annual coupon payments. You're probably going to want to use a formula. Now, a formula is pretty much a present value calculation to find the present value of the face value, and a present value annuity formula to find the value of these coupon payments. Pretty simple, honestly. You just take this for the coupon payments, take this for the face value, you add them up, you get the price. Again, the same bond in formula form is just right here. You have this, which will find that value of the coupon payments, $5, because you're receiving $5 every coupon payment. 10 is the interest rate, 3 is the amount of coupon payments. This is how you're going to find the present value of the face value. You add them together, and you get the price of the bond. Pretty simple. It's just being able to take the values from the questions and being able to apply them in the context of the formula, right? Being able to know what the formula wants and what it's going to give to you. The third type of bond is semi-annual coupon bonds. That just means that you're receiving a coupon payment every 6 months. Now, when they give you values, unless they're explicit about it, that coupon rate is going to be an annual, right? So if it gives you a coupon rate of 5%, that means that on the annual, right, you're going to be receiving 5% of the face value, $5. But in actuality, you're going to be receiving 2.5 semi-annually. This interest rate is effectively a semi-annual APR. Again, unless they say it explicitly, you're going to assume that if it's a semi-annual bond, that interest rate that they give you is a semi-annual APR. So you just apply it all the same way here. This is pretty much just a semi-annual annuity with a semi-annual present value formula, right? Pretty simple. It's just now in the context of a bond. This is, again, just laying out what's in that formula. You're going to get the price of a semi-annual bond in that sense. So the fourth type of bond, even though it says 3, is perpetual bonds. Now, again, it's just the same thing. It's a perpetuity, but it's now in the context of a bond. So it's a stream of fixed coupon payments. The first cash flow, again, occurs 1 period from now, and these bonds never mature, which means that the bond value for the bond holder never receives their face value. So first of all, to find annual interest payments, you just take the face value times the coupon rate, and you divide that by the interest rate. Pretty simple. All of these bonds, when we get to YTM, when we get to yield to maturity, they all use the same basic kind of rules. They're just different ways of doing the same thing. So now let's do some practice questions working with each of the different bonds and being able to value each of those bonds. So, first practice question is value the following bonds with a face value of $100 and an interest rate of 8%. So the first thing is a strict bond with a maturity of 4 years. So again, we're just going to be using that present value formula because it's just that face value of $100 that we need to discount. So we're going to take $100, we're going to discount that by 1 plus 8%. 2 exponent 4, 4 is again that period, the 4 years that we need to discount it. And we're going to get that this bond is worth $73.50. Next bond, coupon bond. I guess we're going to assume that it's an annual coupon bond with an 8% coupon rate and a time to maturity of 5 years. Now you'll notice that this coupon rate is the same as our interest rate, right? So, obviously we haven't covered that in the package, but you guys should be able to immediately notice that, in this simple situation, that means that bond is at par, right? So the interest rates or the coupon payments are just enough to kind of offset the discount factor of the time value of money, meaning that this bond at the present point is worth $100. It's at par, right? So let's move on. C, semi-annual coupon bond with a 10% coupon rate and a time maturity of 3 years. So again, what we're going to be using is the semi-annual. Sorry, I don't know where my thing are, but we're going to use that semi-annual bond formula right here. This is how we're going to find the value of our coupon payments. Our coupon payments is 10%. Again, that's going to be assuming that that's an annual coupon payment, so it's going to be $5 per period. Again, we're going to assume that this interest rate is a semi-annual APR, so we're going to have 8% divided by 2. Plug all this stuff into the annuity formula. For our face value, it's going to be $100 divided by 1 plus that interest rate divided by 2 to the power of 2 times 3. So again, that's 3 years times 2, which is the amount of periods per year. And we're going to find that if we take the value of the coupon payments, add that to the value of the face value, we're going to be getting $105.24 for our present value of this bond. Moving on to the last bond that we're going to need to value here, we have a perpetual bond with a 7% coupon rate with semi-annual payments. Or sorry, this should say annual payments. That's my bad. With annual payments. So again, we're going to be using that perpetual bond formula. This face value, this F, is $100, that coupon rate, 7%. Pretty simple. Just put that in there. We're going to find that means that on the annual, we're going to receive $7 as a coupon payment. We're going to divide that by 8% is our interest rate. And we're going to find that our present value of this perpetual bond is worth $87.50, which means that we're going to be able to pay, we'd be willing to pay $87.50 for this particular bond. So now let's move into the final kind of section of the class here, the final section of the review, which is basically the qualitative aspects of the bond. Of course, there's still math here, but this is basically understanding the theory that comes behind these bonds. So the first section is yield to maturity. So the yield to maturity is the yield of the bond, assuming that the bond is held to maturity and the coupons are reinvested at the yield to maturity. Make sure you have, if you're going to use the yield to maturity as an actual yield, an actual rate of return, you need to have both of these things. It's held to maturity and those coupons are reinvested at the yield to maturity rate. It's quoted in annual terms. Make sure you keep that. And the yield to maturity is the bond's effective interest rate for valuation purposes. And what that means is that when you have this formula, right, and you're using it this way, and you get more kind of into advanced finance classes, you're going to have situations where your interest rate is going to change over the course of the bond. But in this situation, this R is effectively the yield to maturity, right? So when you use this formula, this R would be the yield to maturity of the bond. So again, these are just the relations, the situations. So if the yield to maturity is greater than the coupon rate, that means that the price is greater than the face value, and that bond is sold at a premium, meaning that the price is above the face value. So I guess if face value is 100, that'll be 105, 110 above the face value. The yield to maturity equals the credit, or equals the coupon rate, sorry. That means the price equals the face value, and that bond is at par. So again, that means that coupon payments are just enough to kind of offset that time value of money to make it so the bond in the present is worth that face value with the coupon payments. If your yield to maturity is less than the coupon rate, that means the price is less than the face value, and that is a discount bond. So that's just, make sure you guys can easily fill in a chart like this, right? Because if you can't, it's going to be really hard to be able to kind of apply yield to maturity in your test. Another thing that you might see is current yield. I don't think you actually will, but just keep that in mind that this is something that if your professor went over it, make sure you know that the current yield is the annual cash payments divided by the current bond price. Pretty simple formula, but just make sure if your professor went over that, make sure you know that. And these other 5 things, bond yields are also affected by the real rate of return, or the real rate of interest. That means that, because there's inflation right now, you need to take that into account. You don't need to take that into account, but if you're actually selling bonds, you need to take into account that there's inflation, and money in the future is going to be worth less than money right now. There's the premium for expected future inflation. That's that same thing, moving into the future. Interest rate risk premium, that's the risk that in the future, kind of the market interest rate, the bank account interest rate will fluctuate. Default risk premium, that's the risk that the counterparty of the bond basically won't be able to pay the coupon payments, won't be able to pay you back. And the liquidity premium is basically that, if you wanted to go to the market and sell your bond, you wouldn't be able to without taking a loss. Now, these basically 5 things, I know for some professors you're going to need to know them. You probably might not even need to define them, but they're going to ask you something like, name 3 other effects that could affect the bond yield. So just make sure that you're at least able to list these and at least able to kind of know what they are, right? So just keep that in mind. And then the last kind of section here is the
Is bond yield equivalent to realized rate of return?
Sorry?
Is bond yield equivalent to realized rate of return?
No, we're going to cover the realized rate of return.
Okay,
But the yield to maturity is, again, the yield of the bond, assuming the bond is held to maturity and the coupons are reinvested at the YTM.
What's the bond yield? Like, have we had any formulas for it?
We're going to cover that right now, the rate of return right here.
No, the bond yield. So the bond yield is the rate of realized rate of return. What is the bond yield exactly?
Oh, yeah, that would be the rate of return. Like in this context?
Yeah.
Yeah, it would be here.
Okay.
Well, it would be kind of both, but you only really would need to just make sure that you know that this affects the yield in pricing, so that would be this, but also what you get out of it as well, right? But just in the marketplace, but not in kind of 298 world, but in the marketplace, when they're pricing a bond, they need to take into account this for pricing purposes, right? Yeah. So, that would be kind of affecting maturity, right? But if this risk is realized, of course, that's going to affect your risk rate of return, right? So, yeah. So the last section here, the rate of return, HPR, which is the same thing of HPR that we covered in the past, of a bond is the actual earned annual rate of return for the time the asset is owned. That means if you sell the bond midway through its life cycle, your rate of return is not going to be the yield to maturity, it's going to be something else probably, and that's what you're going to need to find. We're going to do a practice problem that kind of covers that, so let's keep that in mind. So it's expressed in the effective annual terms, which again is that EAR. In the past, this is our formula here. So it's the selling price plus the future value of the reinvested coupons. So you need to make sure that for this future value of reinvested coupons, make sure you understand what interest rate those coupons have been reinvested. You brought them to the point, that you're selling the bond. So say you have $5 here, $5 here. You need to compound them so they're at this point in time that you're selling the bond. And then that's divided. Those are added up, divided by the purchase price to the exponent of 1 over the amount of years that you held the bond minus 1. That's how you're going to find the rate of return for a bond. So let's do the last practice question here. So 5 years ago, Philip decided to buy a bond with $1,000 face value, 10% coupon rate, and a time of maturity of 10 years. He paid $1,064.18 for the bond, and the market yield to maturity at the time was 9%. Today, after he received his fifth coupon payment, just if we're going to simply do a timeline at this point, which is what I would usually do in this situation, he's going to be selling it right here at this fifth coupon payment. Well, he's received, he's received coupon payment here, coupon payment here, coupon payment here, coupon payment here, and then whatever he sells the bond for, right? He hasn't got that face value, but that's going to happen in 10 years, right? So that's whatever he's got for the bond. It would be his kind of cash flows in that sense. So today, after he received his fifth coupon, Philip noticed that the market yield to maturity of the bond had risen to 12%. Philip doesn't know a lot about finance, but he knows that a high yield is always a good thing, so he decides to sell the bond. So make sure you remember that at the time that he bought the bond, the yield to maturity was 9%. Now it's 12%. The first question is, does Philip have a good understanding of the link between bond prices and yield to maturity? Well, again, let's look at this formula. If this R, everything was kept the same, this R went up, this p-value is going to go down, which means that you actually suffered a capital loss. Bond prices and yield to maturities are inversely related, which means that when the market yield to maturity of the bond, again, the yield to maturity reflects the price of the bond at the current point. That's what it's usually used for, as a reflection of the current price of the bond. So when the market of the yield to maturity rises, that meant that the present value of the bond drops. When Philip bought the bond, it was at a premium, meaning that the yield to maturity was less than the coupon rate. And when he sold it, it was at a discount, meaning that the yield to maturity was greater than the coupon rate. Philip made a capital loss, so he did kind of the wrong thing. So make sure you guys recognize that, because almost guaranteed if they're going to try and trick you, they're going to ask you a question like this. They're going to ask you the link between bond prices and yield to maturity, right? So just make sure you recognize that when yield to maturity goes down, bond prices go up. When yield to maturity goes up, bond prices go down. Inversely related. So what price did Philip sell the bond for? So we can see that he sold it at the end of 5 years, which means that for the bond's purposes, they still have 5 more years to go, plus that face value, right? So which R are we going to use? Well, we're going to use the R that's kind of relevant right now, which is the market yield to maturity of the bond. The C is still the same, $100. That's the coupon payment, 10% times the face value. Again, interest rate is that 12%, the yield to maturity that we have right now. And then our N, make sure you guys recognize that there's only 5 years left in the bond. Even though our total of the bond is 10 years, when he sells the bond to someone, they're only going to get 5 coupon payments and 5 years of discounting for the face value. So the N in this case is going to be 5. You add up the value of the coupon payments and the value of the face value, and you're going to get that he sold the bond for $927.90. So, assuming that he reinvested his coupons at a 5% interest rate over his holding period, what was Philip's ROR on his investment? So, again, here's our ROR formula here. So we have our selling price right here. We have our purchase price right here. All we need to find out now is the future value of the reinvested coupon. So it says right here that he reinvested his coupons at at 5%, which is of course less than the yield to maturity of the bond. So we can't just use, we can't just use this 9% or the 12% as our yield. We need to find that using the ROR formula, right? So again, this is just a simple annuity. Future value is $100 times 1 plus 5%, which is the relevant interest rate in this case. We have 5 coupon payments, and we're going to find that the future value of those coupons that he received during this period of holding the bond is $552.5631. Now, when you're doing your midterm, I recommend when you're kind of in an in-term calculation, you round to 4 decimal places. Anything less than that, if you're going to 2 decimal places, you're really not getting the full, you're not getting all the information. Now, I think some professors, depending on who you have, would be okay with that. Some professors might even want you to just keep it in your calculator, but I recommend that if you keep it to 4 decimal places, most of the time your professor is going to be happy with that. And so you take this which is this value right here, the future value of the free invested coupons. Plug that into the formula. 1 divided by 5, which is again the amount of years that he held the bond, minus 1, and his return for holding the bond for 5 years was 6.83%. All right, thanks. So that's the end of the session here. So if you have any questions, feel free to ask me, and just make sure that you guys do that survey really quickly. Obviously, not as many people are here, so that means you have a really good chance of winning that Starbucks gift card. So thanks a lot again. If you guys have any questions, again, don't feel scared to email me or anything like that. And good luck in your midterm. Thanks.
I got a question about conceptually. I was just wondering how.
So you're wondering how to conceptualize the rate of return?
Yeah, so I understand. So I think I understand. So this, everything up here is future value, right? Your selling price, future value, you bring it all to that date. Purchase price is the present value. What exactly? I'm sure this does something to balance it out, but do you know conceptually what it does? I understand when you put like a negative exponent.
This isn't a negative exponent. This is 1 minus.
Yeah, but I understand for other things when you put a negative exponent, it brings it back. Periods when you put a positive, it's compounding. What does this do?
Okay, think of it this way, right? So if we have kind of a value, right, where we have 1 plus r, or 1 plus r, right? If we want